Therefore, all three triangles are right triangles.
Hey, how do you feel about this?
Okay, what else? Wait, just what else?
We gotta use some measurements. That's why you have a rule.
So they'll have the same size.
No, they don't have the same size.
I mean,
Use measurements like I did with David and Parker.
Angles and degrees. So, like for instance, this angle right here, right? This is 90 degrees, right? But this triangle also has 90 degrees, and then this has 90 degrees. So I could just. Right, so this has 90.
I hate drawing lines.
You're off
Right. So
Make sure you all agree. Yeah.
And the only two things these two have in common is they have the same weight of border legs. I hear what you're saying though, you're right, I'm just saying one thing
Why don't you use that one for one of them and then do the other one for the other?
that's what I was saying.
Okay.
The truth there.
should we use inches or centimeters?
Inches.
You think what's better, is inches or centimeters?
Makes no difference.
I'm gonna go off this.
What are you doing, inches?
Yeah, 6 inches.
What you do is, what did you discover, and what two questions are you gonna go over? What are the two questions?
How do you know you're corrected?
How are they similar, and
Why do you know that?
why do you know that? Who wants to be brave and fill themselves out there first?
Okay, one of the ways that we know that they are similar is that they are all right angles, so they all have at least one 90-degree angle in them, and that that's what I have. Anything else from you guys?
How do you know you're right?
How do we know we are right?
Like, how do you know that makes them similar?
Because the line that we had used that are to make perpendicular to our hypotenuse on this line, since the lines are perpendicular, that creates a 90-degree angle on either side of the perpendicular lines. So
Okay,
that's what
let's move around the group. This group.
So we said how are they similar? They all have the same degree angles. They all have the same amount of angle.
What do you mean about they all have, give me the number, how many?
Okay, well, we only have one similar in its 90-degree angles,
Okay.
and y is the perpendicular bisectors.
Perpendicular bisectors, what does bisector mean?
It's cutting it directly in half.
Okay, we're gonna come back to that word in a second, over here, this group.
So we drew our measurements on the paper,
Uh-huh.
and so they're both 90-degree angles, like everyone else said, because it's perpendicular bisector, which also makes the top two angles the same to each other, but we don't have protractors, so we don't know what those are, but they're the same. And then the leg for each triangle is the same, so they have a similar leg, two similar angles.
Interesting, so listen, they took it a little step farther. Next group, slide over.
So basically we measured the sides of the triangle and compared with the calculations you showed us. The smallest side with the smallest side of each triangle and the hypotenuse
Listen
with
to
the
this.
hypotenuse. And basically the numbers were pretty similar.
How? How do you know this?
How do I know
Like
this?
what, give me a little more specifics. You're on the right track here.
No, basically what I did was I multiplied I did the calculations you showed us.
Okay.
Yes. And I compared the hypotenuse with of the bigger triangle.
Can I
with the
see your
hypotenuse.
calculations? Let's put them on the overhead.
Yeah.
See what we're talking about here. So I'm going to throw up on the overhead here. Take a look at the math. See what you did. Can you tell me what numbers come from where? Where'd you get those numbers from?
So basically the 21
Shh, listen up.
Is the hypotenuse from the small triangle.
Okay,
The 27.7 is the hypotenuse from the bigger triangle.
okay.
And the 13 is the smallest side of the small triangle, and the 17 is the smallest side of the bigger triangle.
Ah, and did they come out similar?
Yeah,
Cool. How do you guys know you're right?
because the numbers are similar.
Well, think about my David and Jacob example. If I just measured once, did I know I was right?
No.
Okay, so you're on the right track, but you're not selling us that we know you're right yet. Let's move over here to this group.
Every triangle adds up to 180. Or all the sides add up to the angles add up to 180. They all have 90-degree angles. So
Listen.
how this is a perpendicular bisector, that splits up to 45. And that one's a 90, so that one must be a 45. So it would be a 45, 45, 90. So same thing with this side.
Do you have the math to prove it? Because you're assuming right now. Can you back that up?
No.
Okay, and I like the honesty on it. Let's come over here to this group.
That's right.
So we basically
Okay,
have,
good.
we basically have the same thing everybody else did, that since this is a perpendicular bisector, these two angles and this round straight line have to be 90. So every single one of these triangles has a 90-degree angle. There's a small one, a medium one, and a little spivver. And that's about all we got. We measured our sides.
Let's go back to Rini. What do you got?
Okay, so David found a way to prove it on here. He has what Ricardo got, but then he proved each side is.
Okay, so hold on to that. Now, there's two things to talk about with triangles. What are the two things in triangles that we can talk about?
Sides and angles.
Angles and most groups are talking about. But there's a tool that you need to find angles. What's that tool? Did I give it to you?
No.
No. So do you think I want you talking about angles? No. What tool did I give you? And what does a ruler measure? All right, there's a reason I'm limiting your tools here. Which group went down the venture of measuring sides? Point to the group. All right, you are going to get back in your group, use the information you got from each other, and I still need the question answered. How do you know they're similar? How do you know you're right? You got 5 more minutes, folks. Go.
We didn't get to finish all like the measurements of all the triangles, but we did do the big one, and we used the Pythagorean theorem.
Can you put it on the camera? So we got math to show us. You can look on the overhead.
So since we measured our big triangle, the height was 11 inches, and the other leg was 8.5, and the hypotenuse was 13.75. So we just did all that. We got 121 plus 72.25 is.
What'd you do to get those? You did what? What's that called?
Squared them.
What's it called though?
Next one. What do you mean?
Then you're doing a formula. It's called
A
the.
squared plus B squared equals C.
And that's called the.
Pythagorean theorem.
There you go.
And then, so that equals, that added up together equal 193.25 was about equal to 189.065
Similar?
Yeah.
Cool. How do you know you're right?
with my mouth.
So just like I did one measurement, you only have one measurement,
I have all 3 of them.
but it's still only measuring one component. So you're on the right track. You showed some similarity, but we need to have full confirmation. Let's go this way. What do we got? You got math to show us? Should I put it up? Math? Or do you want to talk to us?
We couldn't figure it out very well, so.
Ooh, talk to me what you tried to do though. Somebody, what you tried to do up here?
Okay, so, for the 11 and the 23, we measured the leg of our smallest triangle and the leg of our biggest triangle.
Uh-huh.
And then we cross multiplied those, so about 460. And then 11 and 27 is, oh, I did that one. 20 and 27, those are the hypotenuse. So we cross multiplied those, and got 302.5.
There's a math error in here. Not their calculations, their setup. Anyone see it? Based on their words.
15.7 on top of 15.7, right?
As a matter of fact, Nate, I heard you say something in your group there. We're gonna pause this. This is what I do. I need my my scissors up here, rulers up here,